All right, this is example number 2. So again, we're trying to eliminate. So it doesn't matter which variable you eliminate ever. It never matters. You can always do both. It's just that sometimes one is easier than the other. So let's look at example 2. So in example 2, remember, in order to eliminate, we need that when we add the two equations together, that one of the variables eliminates. So that means we need something like a 3x, and then that'd be great if this was negative 3x. We need a 2y, and that'd be great if this was negative 2y. Or maybe if this is 2x, that'd be great if this was negative 2x. This is 6y, so this would be great if this was negative 6y. So of those options that I gave you, which one can we do really easily? Can I make 3x into negative 2x? I can, but I have to multiply by a fraction. Can I make 2y, can I make 2y a negative 6y? I can do that pretty easily. Can I make 2x into negative 3x so that they cancel? I could. Again, I'd have to multiply by a decimal. Could I make 6y equal to negative 2y? Sure, but I'd have to multiply by a fraction again, negative 1/3. That doesn't sound fun. So one of those options was great. It was to make this 2y a negative 6y. I can do that really easily. And again, I want them to be opposite signs because when I add them, I want it to become 0. So we are going to take that top equation. So let's number those equations. Again, I'm going to write them more off to the side this time. Okay, equation 1 and 2. And we're going to take the top equation and we're going to multiply it by negative 3. Why negative 3? Because that'll make this a negative 6y, which will cancel with this 6y when we add. All right, put parentheses there. And we're going to put a negative 3 here. We got to remember to distribute, right? And then times negative 3 on the right side. Don't forget that right side. All right, so we're going to do this. We're going to multiply negative 3 to both of these, and we're going to multiply negative 3 to the right side as well. And look, guys, I'm just going to write it right underneath here, okay? So negative 3 times 3x gives us negative 9x. And then we have negative 3 times 2y, which would be negative 6y, is equal to, on the right side, we have to do 6 times negative 3, which is negative 18. Okay, so that's our new equation number 1. That's our adjusted equation number 1. This is equation number 2. So we're adding those two equations together. Okay, so I'm adding these two. So I'm going to go ahead and come over here and put a plus sign. Need to move this. I'm going to put a plus sign here to remind myself I'm adding those two equations. And again, these are nicely written in standard form. So we have the x and the y term both on the left side, then the constant term on the right in both equations. X, y, constant. And then they're nicely stacked so we can combine like terms. But you got to be careful. Just remember that you can't add terms together unless they're on the same side. So these are all on the left side so we can add them together. These are on the right side so we can add them together. And over here, only add like terms. Only can combine like terms. Okay, so let's do that. We have 2x plus a negative 9x. So that's going to be a negative 7x. Okay, and then 6y plus a negative 6y or 6y minus 6y. That's 0. It eliminates. That's exactly what we wanted to happen. And then on the right side is negative 17 plus a negative 18 or just minus 18, which is negative 35. So you have to be careful here. A lot of you like to say negative 17 minus a negative 18. There are not two negatives here. There's only one. So it's either negative 17 minus 18 or negative 17 plus a negative 18. Gets more negative, negative 35. Then we can finish solving. Divide each side by negative 7. This is an easy one-step equation now. And we get x equals, use a calculator. If you don't know, that should be positive 5. And that's what x is equal to. And again, the rest of the solving, guys, is just like what we've been doing this whole time, a substitution. So the only difference between this elimination and 8.3's elimination is you had to multiply by something first, a number other than negative 1. Sometimes you didn't have to multiply by anything in 8.3. And the only difference between elimination and substitution is this initial setup that we do. The rest is the same. Okay, so now that we have x equal to 5, I'm going to pick one of the original equations. Again, always use original equation because you could have messed up when you did something to one of the equations. And also in these cases, you oftentimes make them bigger. Like these are bigger numbers, so we don't want to do that. Take one of the originals. I don't care which one you do. Let's do, how about equation number 2, just for fun. So I'm going to do equation number 2. And it says 2 times my x, which I know is 5, plus 6y is equal to negative 17. And I just have to solve that. So that's just equation number 2 copied with x. Instead of x, we have it 5 plugged in because that's what x is equal to for this system. All right, so then we have to isolate the term with the variable. So we have to get rid of this, but I got to know what that is first. So 2 times 5 is 10, plus 6y equals negative 17. Easy two-stepper. Get the 6y by itself, so get rid of that 10. Minus 10 to both sides. We get 6y is equal to negative 27. And then our last step, undo that multiplication, we're going to divide each side by 6. So y equals, get out that calculator, it is going to be a decimal. And so when you put that into your calculator, you should get negative 4.5. And that's y. All right, we've got x, we've got y. We know it works in equation number 2 because I just used it to find y. And so we need to check it in equation number 1. So I'm going to write check. And equation number 1. So equation number 1 reads 3 times my x, which we know is 5, plus 2 times my y, which we just said was, I did not leave myself enough room there. Okay, negative 4.5. Is that really equal to 6? So that's what we need to confirm. We need to confirm that this solution, 5, negative 4.5, also works in equation number 1. So we just have to confirm that this is true. So again, order of operations, we have multiplication, addition, multiplication. So we have to do these products first, then we can add them. Or you can just plug this whole thing into your calculator, see what you get. I'm going to do it step by step. 3 times 5 is 15. 2 times negative 4.5, if you're not sure, plug it into the calculator. But it's negative 9, so we're going to add negative 9. And is that equal to 6? And yes, that's just 15 minus 9, and that is 6. So we are correct. So as always, our final answer is going to be written as a coordinate point. X comes first, so it'll be 5, comma, negative 4.5. And that's it for example number 2.